Hello and welcome to Textbook Engineering Problem. Today we're working out of Elementary Principles of Chemical Processes, 3rd edition. We're doing problem number 3.20. Certain solid substances known as hydrated compounds have well-defined molecular ratios of water to some other species, which often is a salt. For example, calcium sulfate dihydrate, commonly known as gypsum, has 2 moles of water per mole of calcium sulfate. Alternatively, it may be said that 1 mole of gypsum consists of 1 mole of calcium sulfate and 2 moles of water. The water in such substances is called water of hydration. More information about hydrated salts is given in Chapter 6. Solid gypsum is formed in a crystallizer and leaves that unit as a slurry, a suspension of solid particles in a liquid. Of solid gypsum particles suspended in an aqueous calcium sulfate solution. The slurry flows from the crystallizer to a filter in which the particles are collected as a filter cake. The filter cake, which is 95% by weight solid gypsum and the remainder calcium sulfate solution, is fed to a dryer in which all water, including the water of hydration in the crystals, is driven off to yield anhydrous, water-free calcium sulfate as product. A flow chart and relevant process data are given below. Okay, 3.20. Okay, so we've got solids content of slurry leaving the crystallizer. That's 0.3 kilograms of gypsum per liter of slurry. Then we've got calcium sulfate content of slurry liquid. Got a certain amount that's of salt dissolved into the liquid. So for every 100 grams of liquid, we have a certain mass of salt in that liquid. The specific gravity of the solid gypsum is 2.32, and the specific gravity of the liquid solution with the salt content is 1.05. We've got a diagram here. We've got aqueous solution of calcium sulfate going in to a crystallizer, okay, and then from there that's going into a filter, and then from the filter we've got the filtrate and filter cake. Then the filter cake goes into a dryer. Water vapor comes off. And solid calcium sulfate comes out. Now it says, A, briefly explain in your own words the functions of the 3 units: crystallizer, filter, and dryer, for part A. Okay, so part A, the crystallizer turns the aqueous bound calcium sulfate into a solid. So the stream coming out here contains solid calcium sulfate. So it's allowing, this is probably like some sort of like super saturated solution, but it's all water bound, so it's not a slurry, but then it comes out of the crystallizer as a slurry. And after it comes out of the crystallizer as a slurry, meaning it has solid particles in it, then you can filter off those solid particles. And then you have a filtrate, which is an aqueous stream. You'll probably recycle some of that back around this way. So the filter gets rid of those solid particles, some in the filter cake, and then some you are putting your calcium sulfate back into this crystallizer. And then you have probably some sort of feed stream that has a higher concentration of calcium sulfate. Or maybe this is a low enough concentration that you don't need to do this. And then this just goes to waste or something like that. This filtrate goes to waste, but yeah, whatever. The main purpose of the filter is just to separate the solid particles of gypsum out. Then it gets sent to the dryer, and obviously that's pretty self-explanatory. Dryer is water, vapor, and solid. So you just remove the hydrate particle and whatever else is in there. There's probably, they said it was 5%. They said there was like 5% solution in the filter cake, so it also removes all that. So okay, now part B. Take a basis of 1 liter of solution leaving the crystallizer. Calculate the mass and volume of solid gypsum. The mass of calcium sulfate in the gypsum, and the mass of calcium sulfate in the liquid solution. Okay, so we're just analyzing this stream right here and nothing else. So we've got solid gypsum and a liquid stream coming out of the crystallizer. Okay, so let's draw a close-up on this crystallizer. Okay, we've got our volume is 1 liter. Okay, so we have 1 liter that goes in, and then what comes out. Okay, and what goes in is a sulfate aqueous stream. Okay, and then what comes out, what information did they give us? They told us that, okay, so they said solids content of slurry leaving crystallizer. Okay, so they said we have 0.35 kilograms of gypsum per liter of slurry. Okay, so if we have a liter going in, or coming out of the, we have a liter coming out of the crystallizer, then we know that we've got 0.35 kilograms of calcium sulfate or gypsum. Okay, so this is how much we have coming out of the crystallizer. This is the solids content anyway. We also have a liquid amount that's coming out. Okay, so then there's a slurry liquid. So this is the solid coming out, and then we have a liquid coming out. And that liquid coming out is, okay, so if we have, let's figure out the volume of solid gypsum coming out equals the mass over the density, and that equals, we've got 0.35 kilograms of CaSO4 2H2O divided by the density. what's the density of gypsum? We know that's right here. They gave that to us, so 2.32. So if the specific gravity is 2.32, then the density is 2320 kilograms per meter cubed, okay, of the gypsum. Okay, so then we've got 2320 kilograms per meter cubed. Okay, and this equals 1.51 times 10 to the minus 4 meters cubed. But then turning that into liters, we have 0.151 liters. Okay, so that's the amount of volume of solid that's coming out. And now it asked us how much calcium sulfate is in the gypsum. Okay, in order to know that, we need to go to our molar ratios and things like that. So let's get our molar masses figured out. So 172.2 kilograms per kilomole. Okay. Now that we've got the molar masses of all these things, now we can take our mass calculation up here that we got. We have 0.3 kilograms of gypsum, and we can say, okay, how many moles of calcium sulfate do we have? Okay, so mass of calcium sulfate. So first we say, okay, we've got 0.35 kilograms of gypsum for every, how many moles of gypsum is that? Well, 172.2 kilograms per mole gypsum. Okay, and continue underneath here. So now we have moles of gypsum, and now we're going from how many calcium sulfates are there in every gypsum. Well, there's one calcium sulfate. There's 1 kilomole of calcium sulfate for every kilomole of gypsum. Okay, now we say how much mass is a kilomole of calcium sulfate. Okay, do this multiplication, and that we have 0.277 kilograms of calcium sulfate in 0.35 kilograms of gypsum. We have 0.27 kilograms of calcium sulfate. Makes sense. You'll have a little bit less because of that water weight. Okay. Finally, it says, and calculate the mass of calcium sulfate in the liquid solution. Okay, so in the liquid solution, first we need to know how much volume of liquid solution we have. So we do know how much volume we started with, which was 1 liter, and then we know that some of that volume was solids, and we know how much volume that solids was. It was 0.151 liters. So the volume of liquid solution is equal to, this is an L for liquid, volume of liquid solution equals 0.151 liters, because we're taking how much volume we started with and we're subtracting out the solids volume, so the rest should be liquid volume, and that equals this much liquid. So that's how much volume we have, but now we need to turn that into mass. Okay, so mass of liquid, we know the specific gravity, and we know the density then, so we can get 0.849 liters of solution and 0.5 kilograms per meter cubed, liters in a meter cubed. Okay, and this equals 0.891 kilograms of liquid. So now we have the mass of liquid. We know they gave us this mass ratio of liquid. So we have 0.209 grams of calcium sulfate for every 100 grams of water. And we know that our total mass of liquid is equal to 0.891 kilograms of liquid. But this liquid contains both calcium sulfate and water, okay? So we know that the mass of the liquid is equal to the mass of the water plus the mass of the calcium sulfate, okay? But we know that the mass of the liquid, the mass of the water, if we divide, we know what this ratio is, the mass of calcium sulfate per the mass of the water, or at least 100 grams of water. So from this ratio that they gave to us, we can figure out what this ratio is. And because we know what this variable is, we can solve for this. Okay? So we're going to try and solve for this. So if our ratio can be replaced with this value, that means that I'm going to rewrite this ratio so that it's on a unitless basis, just like this ratio of calcium sulfate to H2O. So that's what we can replace into this number. 1 plus 2.09 times 10 to the 3 divided by the mass of water. And now we can get what the mass of the water is. And that equals, oops, I need a minus 3 there. Sorry about that, minus 3. Okay, and that equals 9.6. That's the kilograms of water. Okay, and if that's the kilograms of water, then we go back to this equation here, and if we know the kilograms of water and we know the total mass that it is altogether, then we can calculate what the mass of the calcium sulfate is. So mass of calcium sulfate equals the mass of the liquid minus the mass of the water, which equals 1.86 times 10 to the minus 3 kilograms of calcium sulfate. Okay, and that is the mass of calcium sulfate in the liquid solution. Okay, so part C, calculate the percentage recovery of calcium sulfate. That is the percentage of the total calcium sulfate precipitated plus dissolved, leaving the crystallizer, recovered as solid calcium sulfate. Okay, so you're only able to recover, let's return to our diagram here. You're only able to recover stuff that came from this stream that goes to the dryer. So anything that comes out here would be stuff that you don't recover, the calcium sulfate you don't recover. The only stuff that wouldn't be caught by the filter, we can assume you've got a 100% effective filter. The only stuff that's not caught by the filter is the calcium sulfate that is aqueous. It just is on a molecular level and passes through the filter because it's dissolved into the liquid. On the other hand, if it's a solid, then you recover it. Well, we have the total amount of mass of calcium sulfate that comes out of the filter, or that comes out of the crystallizer. We just calculated what both of those are, and then we also calculated what this stream was, the aqueous calcium sulfate, and we calculated what this stream was, the solid calcium sulfate. So now we can just calculate the masses, or the efficiency of this process. Percentage recovery. Okay, so we're doing a percent recovery, and that equals 277. That's how much we recover as solid. Okay, how much came out of the crystallizer total? Well, it's the amount that's liquid, dissolved in the liquid, and plus the amount here. So that is equal to 0.279, and that is 99.3% recovery. So you're getting nearly all of it out. That's great. Okay, and that is it for problem number 3.20. All right, thanks for joining me on this problem. This one was a little bit longer, but hopefully we covered it in enough detail that you were able to follow along and understand the different steps we took. If you have any questions, please put them into the comment section below, and we'll try and start a conversation on the different segments of the video that needed to be covered in more detail. Anyway, thank you for joining me, and I hope to see you in the next video. Thanks. Bye.